Okay, so today we're going to be talking about balancing redox reactions or equations. So we have two examples here. The first line is a single one and the second line is something separate again. So what I'm going to do is I'm going to go through the first one, give you steps on how to do it, and then I'll give you time to do the second one yourself. Okay? So what we want to do is write down our steps first. So over here I'll go step 1. Assign oxidation numbers. Two, identify the movement of electrons. I'm going to say per atom there. 3, workout ratio. To balance. Okay? So for the first one, if I write down, I can just write over it actually. So if I write down the oxidation numbers for each one, so this is an overall charge of a minus sign. So the oxygen usually takes a -2. So for that minus sign to say there, this chlorine has to be a +1. The next one, this is still going to be -2, but I want to keep that -2 charge there. So for each one of those sulfurs, I'm going to give a charge of +2. So the sulfurs altogether will be +4, and the oxygens altogether will be -6, which will give you a leftover of -2. Okay, again, the oxygen is going to be -2 +1 for hydrogen. It'll take the charge that's on the chlorine standards on its own. -2 again for oxygen, and the sulfur will be a +6 and +1 here. Okay, so that's the first step done. Identify the movement of electrons per atom. So you can disregard the ones that don't move or nothing happens to them. So you see the oxygens all have -2, so I'm just going to get rid of that. So it's a bit clearer. And the hydrogen still have +1, so I'm going to get rid of that. So now we're left with the clear atoms that are changing here. So let's talk about the ClO-. Right, so that, if I break that up, it just takes the oxidation number, so that's going to be a Cl+. So from here to here, it goes from a Cl+ to a Cl-. That's going from a +1 oxidation number to a -1 oxidation number. So what's happening there? It's becoming more negative, so it gains 2 electrons. Okay, so if I wanted to write down the half reaction to that, okay, so the half reaction. I'm going to write down Cl+, what it gained, 2 electrons, and that became a Cl-. Okay, so that's as far as I can do for now. I'm just going to create a separate one. So I'm just going to separate this out for the next bit. So I've got that part done. Then we're going up here again to the sulfur. So let's write down S2O3 2- as the heading. Now that S2O3 2- it's going from oxidation number. Oh, sorry. We can say it's going to go from S +2 to an S +6. Okay, so it's going from +2 to +6. So it's becoming more positive. So it's lost 4 electrons. Okay, so what we can write for there is the half reaction. So I'll get my different color again. Okay, so S plus 2 minus 4 electrons this time. And that goes to the S plus 6 state. So that's what's happening there. Now, in your books or whatever you're looking at for revision, it might sometimes say plus 4 electrons, but it will be written as S plus 2, S plus 6, plus 4 electrons. And that's like in algebra, when you bring a minus sign across the equals, it just changes the sign. So I'm just going to leave it as the minus. Okay, so that's what's happening there. Now I want to bring your attention to the important part here, which is the fact that we have 2 sulfur atoms. Okay, so we need to address that. So what I'm going to do is I'm just going to multiply this half reaction by 2 because we have 2 of them. Okay, so that means that in fact we actually lose 8 electrons for the sulfur. Okay, so there is an imbalance, as you see. We have minus 8 electrons here and plus 2. So we need to work out the ratio there. Okay, so for each, basically what we're doing is for each chlorine to the 2 sulfurs that we see up here, which each have an oxidation of plus 2, I'm going to need 4 chlorines or 4 moles of that substance to feed what I have here. To feed the electrons is what I mean. So what I'm going to do is multiply this by 4. So if I do that, that will become 4Cl plus 8 electrons. Gives me 4Cl minus. Okay, so I'm going to move down now and I'm going to start to rewrite my equation. So if I do that here, let's write it over it. Sorry. Now, so that would become 4ClO minus. I'm just going to leave that there for a second. Little gap there. Okay, so I got 4 here, I need a 4 here. I'm going to do it in different colours. Just so it's a bit more obvious. So 4, 4. And now I need to do the S's. Are the S's okay? This needs to have a 2 put in front of it because there's 2 S's now in each side. 4 oxygens in the first section, 3 and 1, so 8 oxygens there and 1 H. So what we can do is just the left hand side versus the right hand side. Chlorine, sulfur, oxygen and hydrogen. So on the left hand side now I have 4 chlorines and on the right I have 4 chlorines. Sulfurs, I have 2. Oxygens, I have 8, 1 and 1. Okay, so if you can see now, looking back up here, if we've kept the ratio or not. So for each one of this, I have 4 moles. So you can write this ratio if you wish, rather than having them as the ions on their own. You can write them as this. And for each one of these on this side of the equation, I need 4 of these. So I've kept that ratio 4 to 1. And then it's just checking if it's balanced using the left hand versus the right hand sign. Okay? So if you want to pause it now and give your go to the second equation here, and doing the exact same steps and writing the half reactions out to make sure that the electrons on one side of the reaction equals the electrons given on the other side of the reaction. Okay, so what I'm going to do now is I'm going to write out the second reaction over here and do the exact same steps. Okay, so let's see, it's ClO3 minus plus a Br minus plus a H plus goes to Cl minus plus Br2 plus H2O. Okay, first step again was to assign oxidation numbers. So that was a -2, that's a +5, a -1, +1, -1, 0, +1, -2. Okay, so get rid with your rubber of the ones that don't change. It's usually nearly always the oxygens and the hydrogens. Gotten rid of, okay? Now, see what the transfer is. That's going from a +5 to a -1. And that's going from a -1 to a 0. So breaking it up into 2 sections. Let's take a look. So the chlorine is going from a +5 to a -1. So that has gained a bit more negativity. So it's gained 6 electrons. If I was to write the half reaction, okay, so that's that done. Then the bromine, it's gone from a -1 to a bromine with no charge. Sorry, that should be not squared, but down here. Okay, so with the no charge, okay? So that's going from a -1 to a 0. So what's happened is he has lost 1 electron. So you can already see the ratio that's happening here. So I'll just write the half reaction for you. Okay, so there we go. Now, writing this up. So I need to figure out the imbalance. And if we look at the amount of electrons lost versus gained, we need to sort that out. So the ratio of the ClO3 minus to the bromine, for every 1 mole of this, to balance it out, I need 6 of these. Okay, and you can do that just by multiplying this by 6. So that becomes 6Br -1 minus 6 electrons goes to 6Br. Okay, so I need to keep that ratio. So I'm ready to fix this up here. So 1 ClO, and I need 6. I'm going to put a whack of 6 in here. This Br2 here, so I'm going to put a 3 here. Figure out the rest, if it's okay or if it's balanced. So looking at the oxygens, I have 3 oxygens on the left-hand side. So I'll put a 3 here to get 3 on that side. And I need to put a 6 here. Okay, so again, left-hand side versus right-hand side. Cl, Br, oxygens, hydrogens. 1, 1, 6, 6. Oxygens is 3, 3, 6, 6. So it's balanced, and I've kept that ratio, as you can see up here, 1 to 6 moles. Okay, so that's that. Hopefully that